I'm glad to see you in our new video series about another great anynines data service, which is part within the anynines platform. My name is Patrick Hartz, and this time we will talk about the anynines messaging service. Like in previous video series, we split the journey into 4 parts. In the first part, we will show how to create a service instance and bind it to 2 microservices. The second part covers topics around a deployed service instance, like the scaling of the instance and enabling plugins. Anynines messaging provides features to define HA capabilities on queue level, and it comes also with its own dashboard. This is part 3. In part 4, we will talk again about the self-service capabilities of an anynines data service. I will give a brief introduction about anynines messaging before we start. Anynines messaging is a message broker which supports the advanced message queuing protocol. It is an open standard application layer protocol for message-oriented middleware. In microservices, you can use messaging systems for the communication between several services a system is composed of. You have at least 2 parties, a producer which creates the messages and a client which is able to receive them. Whenever a client is not connected or doesn't respond anymore, anynines messaging can serve as a shelter to preserve the messages until the client responds again. Anynines messaging is based on RabbitMQ technology, which is under open source and maintained by VMware. RabbitMQ can be deployed as a single standalone VM message broker or as a multi-master cluster which supports sharding of the nodes as well as high available queues distributed over several nodes in a cluster. To give you a feeling on how to use anynines messaging, we prepared 2 small microservices with a web UI. One to send messages and a client to receive them. Both are only connected via the message broker. They don't know each other. Like in the PostgreSQL demo, we will use the anynines path as our Cloud Foundry offering. We also assume that you have the Cloud Foundry CLI and the GitHub CLI still installed on your machine. In the video description, you will find the link to the demo applications as well. Let's log in again to the anynines path using the Cloud Foundry CLI. Because of the automation behind the anynines data services, it takes some time until a service instance is ready. So therefore, we start a demonstration by creating a service instance before we push the applications to Cloud Foundry. As we are just interested in the anynines messaging service, we will check out the marketplace and see which plans are available. As you can see, also the anynines messaging offers several service plans. For our testing purposes, we will use the single small plan. As already mentioned, the creation of the service instance will take some time. Depending on the infrastructure underneath the automation, which comes with the anynines data service framework, it will take a couple of minutes. The automation we are using is called BOSH. It is a tool chain to orchestrate virtual machines. BOSH will create the virtual machine for us, then it attaches a persistent disk, installs all the parts of the software we need for the automation, and then is starting the processes. So the service is ready after this step.
A few minutes later.
When we are waiting for the service instance to be created, we can check out the sample application. You can download the repository from the anynines GitHub page. We will find 2 folders in this repository containing both applications. One is the sender, which sends the messages, and the other is the client, which receives the messages. If you've seen the anynines PostgreSQL demo, then you remember that we created a service instance, pushed the application with the no start flag. We waited until the service instance was ready. We bound the application to the service instance, and then we restarted the application so that we can use it. You know that I'm a bit lazy, and with 2 applications this is a bit too complicated. There are too many manual steps. This time we will discuss an easier and smarter way to push 2 applications at the same time to Cloud Foundry. For this purpose we will create a manifest. The demo application, the folder, is containing already a manifest file. Last time we also used the manifest file, but we didn't talk about it. We will also not go too deep into details this time, but I will explain what we are doing in this manifest file. So let's open the file. As you can see, the manifest file contains 2 definitions for both applications. The first is a definition for the receiver application, and the second is for the sender. The name property defines the name you can see later on in the Cloud Foundry application overview. The memory is a definition how many memory Cloud Foundry reserves for this application. As it is an application written in Go, 64 MB is totally enough. Random route tells Cloud Foundry to create a unique route. Please keep in mind that you are not the only one using the anynines path. If you have your own domain, then you can connect your domain to the anynines path and push applications which are then reachable via your domain. Instances tells Cloud Foundry to spawn just one instance of this application. Path tells the Cloud Foundry CLI where to find the source code. As it is a Go application, we have to define the Go build pack. And now the interesting part. In the services section, you can define service instances. Cloud Foundry automatically binds the application to the service instance. I don't want to touch the manifest file for each environment. So you can define variables in this file. Just introduce it with 2 brackets and then give it a name. Pushing 2 applications at the same time just needs 1 command now. But stop! Before we can push the application, we should check if the service instance is already deployed. It seems okay. Okay, let's push the app. Push the apps.
A little longer than a few minutes later.
All the parts we did the last time manually is doing the Cloud Foundry CLI for us now. Pushing both applications, creating the bindings, and then starting the applications. When the applications are pushed, we can open the UIs in the browser and send a message to the queue so that the receiver can receive the message. Let's create a message the receiver should show. Despite this is not the best example for applications using a messaging broker. The idea of what you can do with the anynines messaging should be more clear now. Also, you should know what is behind the anynines messaging, and we discussed a way to push 2 applications to Cloud Foundry at the same time using a combined manifest file. In the next video, we will take a closer look into the anynines messaging service itself. Check what we can do to adapt the service to our needs, and also tweaking our service by enabling plugins. If you like our content, leave a like, push the subscribe button and follow us on YouTube and our other social media channels.